Hi, this is Mrs. Clark, and I'm going to go over this Desmos activity, finding slope from a table practice. I'm going to go over just a couple of slides here that I thought pick out a couple different kinds of problems that we will see throughout this practice, and then as you're going through, you can do the practice and check to see if you're correct. So I'm going to show you how that works out as well. Some of the slides will self-correct your answers, and some of them won't. So I'll probably pick to go over the ones that don't self-correct so you can save the other ones to do on your own. All right, so on slide 1, we are trying to use this table to find the rate of change. So one thing that we should remember is that rate of change is the same thing as slope. So here they're just asking us to find the slope, right? But when I'm looking in the table, I don't really know if this is a constant rate of change or not. So sometimes I'm looking to check and see if it's a constant rate of change. If they're asking for the rate of change, we can kind of assume that it's a constant rate of change, unless it's a multiple choice question where it might be an option to choose not a constant rate. So when we find the slope, let's remember, we always do change in y over change in x. One thing I didn't do really great about this slide set that I did, they didn't really leave a lot of room to write on the table here. So I will show you a little bit on how I would do that. There's not a lot of room to write your work out, but we can make do. So what I need to figure out is what is the change in y over what the change in x is. And I need to do it one pair of points at a time. So you can actually use this little pencil tool here, and you can write on your screen with it. I'm going to go down the y's, and I'm going to see how much it's changing. So it's going from -3 to -1. That's an increase of 2, so I'm going to put +2 here. Like I said, you do have to squeeze it in a little bit because there's not a lot of room, so I apologize for that. So that's +2. I'm going to go to the next one. From -1 to +1 is also +2 because I hop to 0 and then I hop to +1 if I'm thinking about the number line. Then from 1 to 3 is again +2. So far, this is looking pretty constant, so that's good. From 3 to 5 is also +2. That makes it really helpful. I just wanted to show you here how I can tell that it's a constant rate of change, right? It's adding 2 every time on the y. Now, hopefully, it's doing the same thing every time on the x also. Not necessarily adding 2, but whatever it's doing, that it's constant over here because this side is constant. So if I look at the change in change in x, I go from -2 to -1. That's only one hop on the number line, so it's adding 1. Then I go from -1 to 0. I'm adding one more hop. Then I go from 0 to 1, adding 1 again. And then from 1 to 2, I'm adding 1 over here. So notice the x's are increasing by 1 every time. The y's are increasing by 2 every time. So this does have a constant rate of change. If I want to find the slope or this rate of change, all I need to do is figure out what is my change in y over my change in x. So my change in y in this case is +2, and my change in x is +1. So my slope or my rate of change, which are, remember again, those are the same thing, is 2 over 1. So all I need to do is go to this little box up here and type in 2/1. And look, my little emoji changed from a mad face to a happy face with heart eyes. So look, if I get rid of it, it looks like this. That means I'm wrong. When I put in the correct answer, I see this happy emoji with heart eyes. So as you go through slides 2, 3, 4, 5, 6, you can check to see if your answer is right each time to see if that emoji changes. And you can use the same method as you go. So that's how to do those first 6 slides. So it might be a good idea to pause the video right here and go practice and do those first 6, get all the way done through number 6, and then come back on because I'm going to go over number 7 specifically and then a few more after that. So go ahead and pause it right here and then try the next few slides. All right, so assuming that you've done slides 1 through 6 now, we're looking at slide 7. I stopped here because this one doesn't check and tell you if you're correct. So I want to make sure that you know you're correct and when I kind of explain this problem with you or to you. It says determine whether the function is linear. So if you remember, the word linear has the word line in it. That first part of linear is line. So that means if I were to graph all of these points, 8, 7, 12, 5 on a graph, would it make a straight line? I don't need to take out a graph in order to answer this question. What this really is asking is, does it have a constant rate of change? So we call that CROC. Does it have a constant rate of change? If it has a constant rate of change, then it will be linear. So I need to do what I did last time in the tables, what I did in the first 6 slides, and is look at the change in y and the change in x and see if it's constant all the way through the table. So let's take a look at the y's first. Y is going from 7 to 5, so that's down by 2. From 5 to 3, that's down by 2. From 3 to 0, that's down by 3, so decrease of 3 minus 3. And from 0 to negative 2, that's down by 2. Okay, let's see what happens on the x's. 8 plus 4 is 12, so this is plus 4. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. So if I look at them as pairs, I want to see if they are the same. So let's take a look at this first pair. The y is changing by negative 2, and the x is changing by positive 4. I look at the second pair. The y is changing by negative 2, the x is changing by positive 4. I look at the third pair. The y is changing by negative 3, the x is changing by positive 4. And then I look at the fourth pair. Y is changing by negative 2, and x is changing by positive 4. Those were not the same every time that I listed them, right? So as I'm thinking about them, the first time it was negative 2 over 4, right? Remember, it's change in y over change in x. And the second time it was negative 2 over positive 4. The third time it was negative 3 over positive 4. And the fourth time it was negative 2 over positive 4. So they're almost the same. It's almost a constant rate of change, except for this guy. This one is different, which makes it not a constant rate of change. So I can say no, it is not a constant rate of change. So I'm going to choose no up here, and then it's going to ask me to explain. Okay, so how can we explain what we just did? I erased it. We'll write it here in words, so it'll be okay. So we can say this is not a constant rate of change because. Okay, so what did we do here? Oh, I spelled because wrong. Because. Okay, what did we do here? We looked at the change between different pairs of points in the table. And let's start with that. The change between different pairs of points in the table was not consistent. Sometimes the rate of change was negative 2 over 4, and another time it was negative 3 over 4. So since those two fractions are not equal, it's not a constant rate of change. Since negative 2 over 4 and negative 3 over 4 are not the same, it is not a constant rate of change. That's a really full answer right there. We included the fractions. We said what was wrong with what we were seeing with the fractions and how that led us to our conclusion of whether it's a constant rate of change or not. Okay, I do want to go over the next one too, because this next slide was a little bit more of a real world situation. We haven't really looked at that too much. So the first part I think is pretty easy, we can do together, and the second part might be a little bit new for you, but it's pretty easy too. We'll get it. All right, so looking at number 8. The average retail price in the spring of 2009 for a used car is shown in the table below. Find the slope. So remember, slope is the same thing as rate of change. So here are our x's are on this side, and our y's are on this side. So we need to know how much this is changing. Well, that's changing by adding 1. And then how much this is changing. Well, I can figure that out by actually subtracting it. So we can do 17, 378 minus 16,157. And when we subtract those, we get 1,221. But this is decreasing. So we're going to say, I'm going to use the text box because this is really small here. It's decreasing by, so negative 1,221. This is increasing by 1. This is decreasing by negative 1,221. So if I'm going to write my slope, change in y goes on top. So negative 1,221 divided by 1. Negative 1,221 over 1 is our slope, or our rate of change. Remember, those are interchangeable words. What does this number mean about this used car? So how can I take this rate and turn it into some context of what this means about the used car? So this negative 1,221 is the value, and the value is going down. So we can say the car's value decreases by $1,221 in 1 year. So this slope or rate of change is giving us the change in the value of the car over a 1 year period. It might continue to have the same rate. We don't know. We only have this 1 year of data. But we could say in 1 year, this is what's happening. So we gave context to the 1, which is about years, because that's our x value. And we gave the context to the negative 1,221. That is our value. That's our dollars, how much the car is worth. Okay, we're going to do more of that in our next unit, but thought it was a nice opportunity to infuse that here. All right, if you'd like to pause and do 9 and 10 again, those are two problems that are going to allow you to check your answers and see if they're correct. And then we'll come back together for number 11, and then I'll show you how to set up number 12. All right, I chose to go over this one because it doesn't tell you if you're right after you choose an answer here. So I wanted to go over this with you. It is a multiple choice question. It has pretty much all of the options here. So also because the numbers in the table are all negative numbers, it can be a little bit confusing to try to tell if it's increasing or decreasing. So I wanted to give you some pointers on that as well. So looking at the y's, I see 4, 9, 14, 19, 24, but they're all negative. So I would normally think this is increasing if these were positive numbers, but because these are negative numbers, the bigger the number is with a negative sign in front of it, actually the smaller the number is. So these are all decreasing. So I know when I go from -4 to -9, I can think about it as the same as 4 to 9. Just remember that it's decreasing. From 4 to 9 is 5, so I know this is decreasing by 5. And from 9 to 14 has a difference of 5, so I know it's getting smaller, so it's decreasing by 5. And same thing here, decreasing by 5. Same thing here. It is important that I know that it's decreasing. Now, if you were like, how do I tell that? I'm really confused with negative numbers. What do I do? You can always use the slope formula. Slope formula tells us to do y2 minus y1 to find out our change in our y. So in this situation, I could have done -24, which is our second number, right, minus the first number, the one above it. So minus -19. You got to be real good with putting your negatives in the calculator when you do it this way. But if you did that, -24 minus -19, it would come out to -5 because this turns into an addition sign. That's just a quick how we can do that if it gets confusing. Okay, so let's look at the x's. They're going to be a little easier because those numbers are a little nicer to work with. So as I look through the x's, 6, 5, 4, 3, 2, 1, those are all spaced out, one whole number, the next whole number, the next whole number, next whole number. It's going from -6 to -2. It's getting closer to 0. So this is actually increasing. So how much are they increasing? From -6 to -5, that's increasing by 1. So as I go down, each one is increasing by 1. Okay. So what I have to decide now, if we look here, we have ones, we have fives, so almost all these answers have ones and fives in them. A couple of things we can think about are the fact that we have decreasing on this side and increasing on that side means our slope is negative, which means it's not going to be 5 and it's not going to be 1/5. So we have to decide, is it -1 over 5 or is it -5? This is the same thing as -5 over 1. So if we remember, our slope is change in y over change in x, right? And our change in our y's was -5, so that goes on the top. And our change in x was +1, so that goes on the bottom. So we're going to choose this first answer as our answer. And that other answer is our trap answer if we accidentally do it upside down. So this is the correct answer. Right? So if we need to explain our thinking here, we can say the y values are decreasing by 5 and the x values are increasing by 1. So rise over run is -5 over 1. And we can remind ourselves that the y's go on top because that's the rise. All right, and so when we move on to the next slide, as we shift here, the next slide is just going to be you doing a couple different problems together and then matching up some pairs. Okay. All right. So looking here, this is a sorting activity. So you'll see we have a bunch of tables. I'm going to move all the tables together just to make it a little easier on myself. And then I have a bunch of slopes. I have something that's not linear or has no slope, meaning it doesn't have a constant rate of change. I have a slope of 3 halves. I have a slope of -3 halves. So those tables are going to look similar. I have a slope of 1/4, and I have a slope of 4. So those are also going to look similar. And I got to figure out which one of these tables has which slope. See how you have this not sign here, this little circle with a line through it? This will change to an applause emoji when you get it correct, when you have all the right things matched up. So if I open up this first one here, and I try to determine what the rate of change is, I can see if I click on it, it makes it bigger, right? So I know from -1 to +3 is going to be increasing by 4. From -1 to 0 is increasing by 1. So you have to decide, is this 1/4 or is this 4 over 1? And then you have to pair it up with the correct corresponding slope. Okay? So say you decide it's 4 over 1. You're going to take this, you're going to drag it, you're going to drop it on top of 4 over 1. Oh, they're going to match up. Once they become together like that, then I'm going to move on and keep sorting. When I get all of them sorted correctly, I'll get a little applause emoji here, and that's how I know I'm right. So you should be set to finish up the rest of these practices. They're all self-correcting, so you'll know if you have them right, and reach out to me with any questions. Thanks for watching.